Hello, this is Matthew, and we're going to cover what blockchain is in just 10 slides. So, what is a blockchain? Well, a blockchain is a way in which you can have a ledger, think of it like an Excel spreadsheet, shared across a distributed network, like a peer-to-peer network, that are controlled by nodes. So, the way that it works is a transaction is sent out to those nodes, and the data is then captured, and then we use what is called a consensus algorithm, such as proof of work, or proof of stake, or a new one which is proof of authority, to be able to validate the transaction and whether or not it should be appended to the ledger. Once it's actually appended to the ledger, that ledger then is updated across all the networks, and what happens is that each record then starts appending to the previous record. So you create a block or series of records that create a complete history of that item. And so that's where the term blockchain comes from. And what's great about blockchain is that the actual data is extremely secure, it's very verifiable, and it's in a open peer-to-peer network. There are two types of blockchain. There's a private blockchain and a public blockchain. Ethereum, Bitcoin are great examples of public blockchain. Hyperledger is a great example from IBM and the Linux Foundation of a private blockchain. There are reasons for both, but we're not going to get into that right now. What we're going to do is we're going to talk about the different types of problems that blockchain addresses. Three key industries where blockchain is going to be significantly impacting is banking, supply chain, healthcare, and personal identity. And the reasons is that there's a lot of third parties and there's a lot of confusion about all of the entries in each of these areas. So if we take one in consideration, such as supply chain, with supply chain, what we can use blockchain for is that if you take an item, and let's say that it is bananas, the banana, when it is harvested, can be the first item in your blockchain, and you can then have a record which says it was harvested at this field at this time by this farming company, and then you can then keep appending to that record as it moves through as it moves through the supply chain. So you start off with the farm, and then you take it to the truck that takes it to the carrier. It may be a ship, it may be a plane, it may be across country, and then eventually it's going to arrive at a store. Each of those key points, you can keep supplementing the data on that item. So if it's bananas, you want them to be refrigerated as they're being transported. So why not add a sensor in the actual cargo container that actually captures the temperature within the container, and then keep updating the records to show if there are any anomalies. So for instance, maybe there's a container loses its refrigeration. You can actually then have the anomaly sent out to the blockchain, and a action taken that corrects that. The whole idea about using blockchain is that you're digitizing your ecosystem, which means you can actually then put in preventative actions that help prevent things such as the romaine lettuce breakout and other issues that have cost millions of dollars to resolve. So what is the history of blockchain? Well, let's just kind of take it through real quickly. There are three key stages of blockchain. There's really what we call blockchain 1.0, 2.0, and 3.0. Blockchain 1.0 is Bitcoin and what happened with the other cryptocurrencies. Bitcoin was created by Satoshi Nakamoto. We don't know who Satoshi Nakamoto is, or whether it's one person or a group of people. But Satoshi wrote a white paper that was published in 2008 as part of the financial crisis that culminated in the release of Bitcoin in 2009, with the first product being a pizza that was purchased on May 22nd for 10,000 Bitcoins. Yep, that pizza is now worth over 40 million US dollars. Incredible. Fast forward a couple of years and we're in 2014, and there are a number of challenges with the existing blockchain environment. Great for currency, but not much else. But those challenges then create opportunities, and with Ethereum, one of the great opportunities that was captured is the ability to create applications that run on the Ethereum protocol in a peer-to-peer network. So you can actually have your application floating across the whole network, take advantage of the global computing power and have global applications running on global computers. Really exciting. And the big part of Ethereum is a concept called smart contracts and distributed apps. That concept really helped evolve into blockchain 3.0. Ethereum released the concept of smart contracts and distributed apps, but Ethereum itself is fairly slow, certainly not at the speed that you need for enterprise systems or global database systems. Blockchain 3.0 technologies such as EOS and the new evolutions of Ethereum as it's evolving as a framework is that you'll be able to do, instead of 6 to 12 transactions per second, you're going to be looking at tens of thousands to hundreds of thousands of transactions per second. Really cool, and as you can see from this timeline, evolving incredibly fast. Key to all of the work that's being done with blockchain is the concept of smart contracts. Smart contracts are pieces of code that are written and then distributed onto the network protocol that you're working on, so such as Ethereum. And the way that you write the contract is very similar in concept to a real world contract. Think of it as your business logic, as a way to be able to have actions and transactions happen. And there are different degrees of smart contracts. The most popular language for writing contracts today is Solidity, but that's changing. Microsoft this week, and this is the second week of August 2018, just released their proof of authority tool set, and proof of authority allows you to now write Ethereum smart contracts, not just in Solidity but in C#, C++, and Rust, which is just absolutely fantastic and huge. You should get into that. It's really, really exciting. With smart contracts, there's a number of degrees of smart contracts. The easiest and basic smart contract to write is a cryptocurrency contract. So if you want to create your own cryptocurrency, you can really, there are templates out there. You can go to Truffle and download templates on how to build out a cryptocurrency contract. You can really do that in half a day to a day of coding with Solidity. Certainly test what you're doing. One of the things that you have to be careful is that once you actually publish a contract to the main protocol, is that that contract is now out on the internet and is now available on all those nodes. So unless you've actually built something into the contract to kill the contract, if you write a certain command, that contract is then living out there. And as with anything that you're programming, if you aren't careful in what you write, that contract can be compromised. And so this is one of the things on security for writing solutions for the blockchain. Blockchains inherently are very, very secure, and the way in which the security is actually down to every single data point and every update to that data. But if you write a poorly written contract, then your poor programming is what can create vulnerability on the work within the data of that contract. So be careful on what you're doing there. The different types of contracts you can write are simple exchange currency contracts, all the way through to really complex contracts. I think you're going to start seeing tools that are going to help you manage these contracts very quickly over the next few months, next couple of years. The pace of innovation is really, really cool in this space. And talking of tools, the best places to go is GitHub and GitLab. There's just tens of thousands of different types of projects out there that allow you to make updates to the different blockchain tools. And what you'll find is with most blockchain tools is that they are open source projects that are available. A couple of companies are doing some really cool stuff. Microsoft in particular, for the last couple of years, have been doing some very interesting things. They have Azure Workbench that was released in May of 2018, and they continue to evolve that product very quickly, which allows you to stand up your enterprise solution for blockchain on the Ethereum protocol very quickly. I mean, you're talking about a matter of hours instead of days and weeks. IBM also is very involved with blockchain. IBM has an opportunity to use Watson as their machine learning to help improve the data and the transactions that are happening, as well as the security of the blockchain. So that's a pretty interesting combination. What's interesting is that a couple of companies are kind of missing in action. Google and AWS, I think, are notably missing in action. AWS in the last few weeks have really stepped up their game and started adding in new features and starting to add some basic tools, but they still are way behind Microsoft and IBM and even Accenture when it comes to being able to support the types of solutions you need within a cloud environment. And Google, hello Google, where are you? You're so awesome, and yet you're missing. So hopefully they'll step up and start adding tools fairly quickly. So a quick look at the blockchain ecosystem. This is one of those pictures where I feel like this should be updated almost on a daily basis because the ecosystem is changing so quickly, but this will give you a overview of the different tools that you should be looking at that are available right now. So to wrap everything up, where are we with blockchain? So blockchain, if we're going to do a reality check, blockchain is in the same space that the web was in 1993. Just tons of potential. But lots of barriers to entry, lots of education that still needs to be done, and people weren't sure what they wanted to do with it. If you go fast forward even to 1996, the innovation that was happening on the web was growing exponentially. The challenges the web had, which was internet connection, physical hardware and devices like computers, and the knowledge on what the digital ecosystem meant to your average customer, were huge. In contrast, blockchain doesn't have those barriers. We are all very digitally savvy. We have smartphones. Over 2 billion people on the planet have smartphones. We are highly connected, and because blockchain is a digital ecosystem, it can be adopted incredibly quickly. So I expect the adoption of blockchain solutions to happen very quickly. I think within the next 5 years, you're going to see some crazy cool things coming out. What does this mean? It means that you within your organization should be starting to look at blockchain at some point or another for how it fits within how you manage your data with your partners, or even how you manage your data with your customers. You can also look at blockchain as a way to advance your career, whether it's writing smart contracts and getting to know Solidity and other similar smart contract technologies, building distributed apps, or even getting in actually working on the protocols that power the blockchain network, such as Ethereum, Hyperledger, Fabric, or EOS. So where can you learn all this great stuff? Well, there's my YouTube channel. Certainly feel free to subscribe to that. But then also, I would encourage you to check out other YouTube videos. There's just tons of content out there. And Udemy have a series of awesome classes that I would encourage you to also look into at very low rates. So there we are. That's blockchain, and we've done this in 10 slides. I'm Matthew David. If you like this video, subscribe, and we'll send out more videos to you in the future.